So, what if our planet has a kind of hidden bioelectric nervous system? Now, I know that sounds like something straight out of science fiction, but a new scientific paper is proposing this really fascinating and testable idea called the Neuro-Earth hypothesis. So let's dive in and break this down and see if our planet might just have a hidden pulse that we've never, ever detected before.
The whole idea really starts with this one profound question. We know that life and the atmosphere interact, of course. But could there be a deeper, more structured conversation happening right above our heads? A dialogue, spoken in the language of electricity and biology.
Okay, to get our heads around this, we first have to look at the planet's electrical background noise. It's called the Global Electric Circuit, or GEC. Just picture this. At any given moment, there are thousands of thunderstorms happening all over the world, acting like little generators. They're constantly charging up the atmosphere, creating this persistent electrical field. It's like a permanent, planet-wide electrical hum.
And right alongside that electric field, the planet also has something you could kind of call a heartbeat. These are the Schumann resonances. They're these electromagnetic waves that are always bouncing around between the Earth's surface and the ionosphere. But here's the really crucial point. The scientists behind this are not saying these frequencies are directly controlling life. No. Instead, they see them as a perfect global clock, a super precise way to measure worldwide lightning and storm activity. It's a tool, not a cause.
So we've got this constant electrical stage set up across the entire planet. But, for there to be a conversation, you need someone else to talk to. And that's where life comes in, leaving its own fingerprints all over the atmosphere. Every single second, life is, it's breathing out. Microbes in the soil, plankton in the sea, they're all releasing billions and billions of tiny biological particles. And these aren't just random dust. They are life's literal fingerprints, just cast up into the sky.
And these biological particles, they play a really unique role. They're called ice-nucleating particles, or INPs for short. Basically, they're like seeds for ice crystals in clouds. But here's the key difference. Unlike regular mineral dust, which works best when it's super cold, these biogenic INPs, the ones made by life, are absolute superstars at forming ice in relatively warmer clouds. They have their own special, cozy niche.
And there's another pathway, too. Marine life releases a gas called dimethyl sulfide, or DMS. This stuff can help form new cloud droplets, which, in theory, could make clouds brighter and more reflective. Now, the scientists are quick to note that while this link seems pretty strong in some places, its global impact is still a hot topic of debate.
So we've got a global electrical system on one side, and we've got these biological particles influencing clouds on the other. The hypothesis at the heart of our story is, what happens when these two seemingly separate worlds actually connect?
And here it is, the Neuro-Earth hypothesis. It suggests that the electrical charges in the atmosphere could subtly influence how these biological particles behave. It's a process called charge-mediated microphysics, but in simple terms, it just means the tiny electrical charges in the air might be giving these biological particles a little nudge, changing how they gather and interact on a microscopic level. It's a physical, measurable feedback loop between biology and electricity.
Now, to make this huge idea actually testable, the researchers framed it using some really cool analogies to neural functions. Now, they are not saying the planet has a brain, let's be clear. But they're creating a powerful framework for turning this big idea into something you can actually measure. For example, check out that first row. They equate memory to how things like ocean heat can persist from one season to the next, or learning, which they think could be measured by tracking how microbial communities evolve over time. It's a clever way to structure the problem.
Okay, so it's a fascinating concept, for sure. But how on earth do you actually go about measuring something like this? How do you even begin to find a tiny signal in all of that planetary noise?
Well, they built a specific tool for the job, the Biopulse Index, or BPI. You can think of it as their detective's toolkit. It's designed to sift through mountains of global data and pinpoint the exact regions and times where this bioelectric connection might be at its strongest.
So to build this index, it's kind of like they're following a recipe. They blend 4 key signals. They take 2 from the electrical world, that's the electric field and the Schumann resonances, and they combine them with 2 from the biological world, proxies for those special INPs, and satellite data on ocean plankton activity. And the process itself, as you can see, is really methodical. First, step 1, they gather all those electrical and biological signals from all over the world. Step 2, they standardize all that data so everything can be compared apples to apples. Then, in step 3, they combine it all into a single index value.
And finally, step 4, they produce a daily global map that highlights potential biopulse hotspots.
But look, this isn't just a modeling exercise on a computer. The true test of any good hypothesis is whether it actually holds up in the real world. So let's see how they plan to do that.
And this part is just incredibly cool. They've designed this whole experimental program using drones, or UAVs, to fly directly into clouds on days where the BPI is high, so they can sample particles and measure electrical fields right at the source. And at the same time, they'll use these controlled lab environments, they call them microcosms, to see if microbial communities respond differently under specific electrical conditions.
The researchers are also really adamant about one thing. Their work is ethics first. They make it absolutely clear that there will be no open environment bioaerosol seeding. Every single experiment is safely contained. This is all about fundamental research, not geoengineering.
So this brings us to the ultimate question, right? What's the goal here? Why does finding even a faint signal of this planetary conversation matter so much?
The really crucial takeaway is this. The Neuro-Earth hypothesis isn't about proving Earth is alive or that it has a consciousness. No, it's about searching for a missing piece in our climate puzzle. Because if these subtle bioelectric feedbacks actually exist, they could be incredibly important for improving our climate models and really understanding how our world regulates itself.
And the scientists are being really realistic about this. They're not looking for a perfect one-to-one correlation. This R-value here just represents the strength of a relationship. Now, in a system as ridiculously complex as Earth's climate, finding a consistent correlation of just 0.2 to 0.4, that might not sound like a huge number, but finding that link between the BPI and, say, rainfall patterns, that would be a monumental discovery. It would be a game changer.
And that leaves us with this final thought. This research, it really opens a door to a new way of seeing our world, not as a collection of separate, disconnected parts, but as a deeply integrated system, just filled with conversations that we are only now beginning to learn how to tune into. So, what else might we discover if we just keep listening?